Today's topic is why do hackers like reverse proxies? Before that, let's go to introduction. Who am I? So I'm Kalpesh. Working as in cloud and application security in miniOrange for last 11 years, and I'm working with proxies from last 5 years, doing uh, providing different solutions, trying different attacks with proxies. Um, so, what is reverse proxy? So before going forward, I'll just if anyone have any questions in between the sessions, you can ask at that time instead of waiting to end the session. So I can answer that during session as well. So what is reverse proxy? Proxy is a server. You can see a server which sits in between your original server and your browser. So if you access a website like google.com, right now what happens is browser interact with the Google server directly. And let's say if we put that behind proxy, so all the browser will instead interact with your proxy and proxy will interact with the Google server. So normally setup is Google server will be only accessible from proxy and the world knows only proxy address. So, okay, so with that you have one more layer here with on top of your original server, and you can put access restriction here and do other put WAF here or anything which you want. You can, all requests are going through you, so all security checks you want to do can be done here. Okay, so before going to hacker use cases, let's see what are some good use cases which can be solved with the proxy. Proxies are originally created for these use cases, not for hackers. So application layer routing. So let's say you have multiple applications. Let's say you have application running on port 8080. Like whenever you run Tomcat, it runs on 8080. Or whenever you run a React application, it runs on port 3000, right? But that does not look good. You can't ask your users to enter 3000, :3000 or :8080 in the browser. So that's why proxy can beautify your URLs. What you can do is /frontend. You can ask /frontend traffic to go to 8080 port, 3000 port, or you can ask /app traffic to go to port 8080 of the Tomcat server or Spring Boot application. So that makes your URLs pretty. And one more advantage is, instead of hosting applications on different domains, you can have it on same domain, like miniorange.com/app1/app2, an example. So with single domain, you can route traffic to different applications running in the background. It can be different servers as well. Then load balancing. With proxy, you can do load balancing. Simplest example is round robin. So every alternate request, the first request you can send to the first server and second to the second server. Then for every alternative request, you can switch between servers so that traffic on your server is managed. With load balancing, you can divide the traffic so that your servers are not can run properly. And even if one server goes down, there's a second server. Then authentication and authorization. So what you can do is, let's say you have APIs at the backend and you want to protect your APIs. And let's say that application is a legacy application. You can't change the code, but you still want security. So what you can do is you can put proxy in front of that application. Proxy can do authentication part. Authentication is just validating who are you, like your password, authenticate you with your password. And you can put authorization. Authorization is what you can access. Like you can only access users APIs, not groups APIs. Or you can access only department one data, and other department data will be protected. So that is controlled with the authorization. Next is caching. You can also do caching at proxy level. So with that, a performance of the website is improved. Yeah, with caching, you can the server request will be served directly from proxy, which are cached at the proxy layer, and your server will not even get that request, so that will reduce load on your server. Then SSL offloading. Um, if you look at all the websites today, they are HTTPS, that is SSL. So TLS handshake is happening between your browser and the original server. But it's some of the cases you can't have SSL certificate, or you can't put the enable SSL on your servers. So in that case, proxy can do the job. Till the browser to proxy, you can keep the connection TLS, SSL enabled, or on HTTPS in simple terms. And behind proxy, if proxy is sitting in the same network as the original server, so behind proxy, the connection can be without TLS. It can be simple, plain HTTP connection. And that traffic cannot be modified, or there cannot be a man in the middle, because proxy and original server is sitting in the same location. So it's safe to use non-TLS there. Then monitoring. With proxy, you get visibility, all the traffic which is going through you, which employee is accessing what thing, performing what actions. Everything can be controlled. Everything can be monitored through the proxy. You can see the report for that. Okay, now let's go to some of the common attacks which are possible with proxy. Okay, so the most common is session hijacking. So as a proxy is something which sits in between the original server and the user or user's browser. Let's say that proxy is from the attacker. The attacker has created a phishing link or something, or provided you the link, and the original server put original server behind that. So in that case, all the traffic is going through the attacker's proxy. In that case, attackers can intercept all the requests and responses. And let's say if one of the response has, whenever you are sending sending request to the original server, the request contains cookies with that. So that cookies can be intercepted, cookies can be logged in the logs of the proxy server, and the attacker can use that cookies to create the session. So cookies are, if you have cookies, you can hijack session it's same like having the session of the user. So until the cookies are valid, until you don't log out, those cookies can be used to create session on different device or attacker's device. Then phishing attacks, very common. So with phishing attacks, attackers create a lookalike domain. Let's say instead of let's say Amazon.com or Google.com, they create a domain which looks exactly similar. Let's say Google.com with triple O instead of 2O. So that you won't even notice that the domain is changed. It's a lookalike domain, but that domain belongs to someone else. So they can trick you to click on click the links. Like let's say if someone posts a link in the forum saying that you can reset your Google password from this link, the domain belongs to the attacker because it is not Google.com. It has a spelling mistake. And it can trick you to click on that, and if it asks you for username and password, you will enter the username and password because UI of that page is also similar to what Google has, and that can get your username and password. Similar cases happen. Sometimes you might have seen, you get emails from Netflix that your card is expired, your Netflix will stop working from tomorrow or next 7 days, and they provide you a link to update your card information. When you click on that link, it is lookalike domain of Netflix having a form where they ask you to enter credit card information, and once the credit card information is provided, it goes to attacker server, not to the Netflix. So with phishing attacks, your credentials or financial information can be hacked. Then request manipulation. So here you can see all the requests are going through proxy, and the job of proxy is to forward the request as it is to the original server, and the response as it is to the browser. But let's say that if the proxy belongs to attacker, they can modify the request, and they can modify the information you have provided in the request. That can be, let's say, manipulating public polls, providing false information. If you are doing submitting some survey, just changing the data you have sent so that the original server or the backend server will receive a different or false information. So attackers can manipulate your request. Content injection. So let's say the response is also coming through the proxy. So attackers can put the malicious code or other things which are like ads or something with which they can get some benefits on the response HTML. Whenever the response comes from the server, it is a HTML page which is displayed in the browser. So proxy can change that page and put some malicious code in that, so that the response which reached to this browser, which is displayed to the user, contains the malicious code along with the original HTTP response. Cross-site scripting, extended version of the previous content response change. So in cross-site scripting, they can put the JavaScript, they can inject the JavaScript, and so you can see this was the original HTML in the black color, but the red color is something injected by the reverse proxy. If that reached to your server, that will run in the browser which will give you alert from. Instead of alert, if you put scripts to read the cookies, send it to somewhere, or other perform some actions on behalf of users. Because whenever XSS is done, in most of the cases, you might have active session in the browser, and when you reach to that server, if you have an active session, and if with XSS, there is a script written to click you some buttons on the web page. So that can like updating your password can be one thing, or submitting some form which can change the settings on the server. So XSS can trick you to do that without even needing you to get logged in, because the link you send belongs to someone who is already logged in. Okay, so we'll see one case study with which we'll hack the Google session. We'll hijack the Google session with reverse proxy. So this is the step-by-step process which normally the attackers follow. So first step is getting your phishing domain. So for this case study, if we are considering Google, so let's see. If I go to GoDaddy, from GoDaddy you can buy the domain names. There are other domain providers as well. So let's say if I go to GoDaddy and search for google.com, I won't get that domain because it is already registered. Google already has the domain, so I won't get the domain. But GoDaddy will show me some results, like you can't get google.com, but there are some other domains available. Like if you notice this looks like Google has extra L at the end. So I can purchase this domain from GoDaddy. So let's say if I have that domain, now next step I'll do is setting a proxy on the phishing domain. To set up proxy, there are two ways. Either you can write your own code, so you can use any language. So like let's say Node.js is one of the language. You can create a proxy in that. You can run the proxy on the domain you purchase and ask that proxy to send the traffic to original Google server. And the second option is there are multiple tools available. Like Evil Proxy is very popular tool. With that, you can it's a UI based, few clicks and you are ready with the proxy. So for this example, I've shown the code here with which so you can see here I created a application running on port 443 on accounts.google.com, which is the phishing domain. And what that application does is it proxy requests to the accounts.google.com, which was the original domain. And other things are just importing some packages. For SSL, there are some certificates. So the main part is this domain proxy all your traffic to accounts.google.com, which is the original server. So what this means is whenever you hit accounts.google.com, which is a phishing domain, and anything you have after that domain on the same path, like let's say if you have /test or /my account, if you put my account at the phishing domain, the proxy will send traffic to /my account of the original domain with exact same HTTP request. If it has GET requests, exact same request. If it has POST requests with POST parameters, it will forward that to Google server. If you have headers along with your request, the header contains cookie information or other headers, so that will be also forwarded to the Google server. So headers are also persisting, which are stored in your browser. So even if there is a session, that will persist, because in every request you are also forwarding the session cookies in the header. Okay, so step 3, we just created a proxy on phishing domain. So now let's try to log in on the phishing domain. So if you notice the domain, it's a account.google.com, and on that I see the same login page because I'm not doing anything extra. All the traffic I'm forwarding as it is to v3 signing identifier of the google.com page original, and I'll get the content the response which HTML response which Google provided me, that will be printed by the proxy. Next step is I enter password, and I'm logged in on the phishing domain. So after my session is created, the next step is the cookies which I got, printing those cookies, because if we are doing session hijacking in this case, so to do session hijacking we need cookies. So the session which created on phishing domain, if you look at that, it has session cookies from the Google. If you look at this cookie, which start with AB as the session cookie of the Google. So the next step, what we need is to get access to the cookies so that we can hijack the session of the user. So we'll modify our code a bit. We'll add this part in the code. So if you look at this code, what it is doing is it's a listener on proxy response. So we haven't added a listener on proxy requested because that is not needed. So what we had done is proxy response listener. So whenever there is a response coming from Google server to proxy domain, we will get the code will go inside this listener. And here what we are doing is set cookie header, which is the response header in every HTTP traffic. We are reading that header and we are just printing that in the logs, so that the proxy server will know that what was the cookie which was set in the user browser. That will be in the logs of proxy server as well. So this will look something like this. If you see that the cookie starting with AB, the session ID associated with the Google session, we got that cookie from the logs. And now the next step is, now the attacker has on the attacker server in the logs, attacker has the cookie. Now if he want to log in into that, get access to that session, we'll simply go in the browser and set the cookie. There is an extension, edit this cookie, available on the This is one of the extension which is available in the Chrome marketplace. There are multiple extensions which can be used to, instead of setting cookie one by one, you can use the extensions to bulk do the bulk operation. All the cookies you got from the logs, with that format, you can set the cookies on in the browser. For that, this tool can help you import. So here, if you look at this, edit this cookie extension, you can paste the JSON format is one of the formats supported. There are other formats as well. So you can just simply paste it there in the JSON format or other formats, and all the cookies will get imported in the extension. And then if you go to, if you look at the domain, now we are on google.com, not on the phishing.com, because the attacker got the cookie. Now he want to just go to google.com and hijack the session. Now he goes to google.com with the extension, import the cookies, and the attacker is not logged in it. But once after the cookies are imported, he just refresh the page, and the same session which was on the phishing domain, the session was in user session. Now the same session is on attacker's machine as well. So that's how the attacker can hijack your session. Now the question is, can MFA save you from this type of phishing? So the answer is no. The traditional phishing approach was attackers were used to create the lookalike domain, same like we had google.com. They used to create traditional the phishing domains with the same look and feel and HTML, but it was not proxy. So what happened in that case is they were able to read username and password on their server, print that on their server, but they were not able to perform multi-factor authentication because that's simple HTML page, just reading username password, not connecting to Google for MFA authentication. So for traditional approach of phishing, MFA was failing. But with proxy, proxy is just an interceptor. It sends all your traffic to backend server as it is, send all your response to the front-end browser as it is. So MFA does not matter. MFA can be bypass. If you user prompt, user will be prompted for MFA code, and if user provide MFA code, your session will still be you will still be logged in the phishing domain if you are using proxy. So MFA of no use in the proxy. So can we bypass that? Is there any other way we can save our accounts from phishing? So there are phishing resistant multi-factor authentications. So what is that is, one example is WebAuthn or your biometrics, your Windows Hello, which you are using on Windows machine. So those are WebAuthn or FIDO2 standards. What happens with that is everything is connected to your domain. So the multi-factor authentication you are doing with the FIDO2 or WebAuthn is associated with your domain. So if you register your multi-factor authentication on google.com domain, and now the there is a phishing domain which is asking for multi-factor authentication, it will fail because the server will validate the domain name. It was associated with the domain name. So normal MFA like OTP, you are using Google Authenticator, app-based TOTPs, those won't work. Even hardware tokens won't work. But phishing resistant multi-factor authentication methods like WebAuthn, FIDO, those can save you from getting your account session hijacked with the phishing domains. So how to protect your users from phishing attacks? So few simple steps: educating your users about whenever you get emails from fake email addresses which look same to your organization employee emails, or contains links like your Netflix card, your card is expired on Netflix, so update your card. So you have to be careful, verify twice which email ID is used where you receive the email, instead of just clicking the links blindly. verify target URLs. So when you are clicking netflix.com, check the spelling if it is Netflix only or it contains some spelling mistakes. So verify target URLs before clicking. And third, which we just saw, um, use resistant MFA methods. So instead of using traditional MFA, you can switch to phishing resistant MFA methods, which I think most of the application have started providing already. And I think that will, even if your users make mistake in first two steps, the third step will stop your users from getting hacked. So that was it. Any questions? Yeah, please go ahead. Brute force, you mean? Brute force cookies, you mean? No, I'll say that is not possible because if you look at Google's example, it use multiple cookies. If you use combination of two cookies, your brute force becomes like highly impossible. If you just I'll give a simple example: username and password, right? If you know username, your brute force becomes easier because you now one key. Entering password becomes easier now. But cookies, but if you don't have username, trying both combinations, it becomes like n square. Sorry, n raised to n. Instead of n attempt, it becomes n raised to n attempt to find that. Same happens with cookies. Cookies is not just one thing; it is multiple. There are multiple cookies, so it becomes n power n. So I think with supercomputers also, it will take. It is highly impossible. That Yeah, in that case, it is possible. If you have just one cookie, if you are using that cookie, also let's say there is a application using 16 character cookie, and it does not have any special characters, just alphanumeric. So in that case, we'll probably can hack that session. Any other questions? Okay, I think no questions. So that's it. If you guys have any feedback, this is the QR code you can scan. Thank you for attending.